Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on radians, and in this video I'm just going to be going through a geometric example where we use radian measures to find lengths, perimeters and areas. However, before I even read the question, firstly we're going to do, because this is a radian measures question, so I've got my class whiz, we're going to put it into radians mode. And the way that you do that is you press shift and then set up. You want number 2 for angle unit and then number 2 for radian. And make sure before you even start answering a question that's on radian measures or anything to do with radians, the first thing that you do is to put your calculator into radians mode. Right then, so here we have figure 1, shows the triangle ABC, so it's a triangle here, with AB equals 8 centimetres, AC equals 11 centimetres, and angle BAC equals 0.7 radians. The arc BD, where D lies on EC, there, is an arc of a circle with centre A and radius 8. The region R, shown shaded in figure 1, is bounded by the straight lines BC and CD and the arc BD. And the first thing that we're going to do is to find the length of the arc BD, or rather I should say that's what you're going to do, because at this point, to get the most out of this, you need to pause the video, attempt this question by yourself and use this as a run through of what you should have done, rather than just passively watching your way through it. So, to find the length of the arc BD, I've got my 2 radian measures formulae written in this box here. The length of an arc is equal to r theta. So for part A, to find this length BD, I just need to do the radius multiplied by the angle. Now the radius is 8 and the angle is 0.7 radians, which means the length of BD is 5.6 centimetres, and that is literally it, that's done. 5.6 centimetres is the length of that arc. Okay, moving on to part B. Part B is saying the perimeter of R, giving you an answer to 3 significant figures. Now R is this shaded region, so in addition to the BD that we already know, we also need CD and we need BC. So let's just have a think about this then. CD, the length from A to C is 11 centimetres, but as this is an arc of a circle, I know that this length here from A to D is going to be 8 centimetres, which means I'm going to be left with 3 centimetres here on my diagram from D to C. So what I now need to do is to work out the length of BC. And how am I going to do that? Well, I've got a triangle here, I know 2 sides, and I know the included angle, so I'm going to use the cosine rule. So, the cosine rule, a squared equals b squared plus c squared minus 2bc cos a, where a squared is the length that I'm trying to find, so I'm going to write there bc squared is equal to b squared plus c squared. That could be these 2 sides either way around, so 8 squared plus 11 squared minus 2 times 8 times 11 times by cos of 0.7. Now that's in radians, we don't need to worry about that because we've got the calculator in radians mode already. So let's just put that in. Okay. Gets me BC squared to be 50.3877, etc. So I'm just going to square root that to get a value for BC, which is 7.098. Okay. So therefore, my perimeter of R is going to be the sum of those 3 lengths. It's going to be the 5.6, which is the arc BD, plus 3, plus that answer there, which to 3 significant figures is 15.7 centimetres. So that's the perimeter of that region R. One last bit there, we're being asked for the area of R, again giving our answer to three significant figures. So, to calculate the area of R, it's going to be the area of the triangle minus the area of the sector. Now, to work out the area of the triangle, I'm going to be using the formula half AB sine C. And to work out the area of the sector, I'm going to be using the formula half R squared theta. Now, go back to the diagram. A and B are the two sides of the triangle, so 8 and 11, and 0.7 is the included angle. So that's going to be half times 8 times 11 times my sine of 0.7 minus a half, my radius was 8 and my angle 0.7. So I'm just going to work that out as two separate calculations. So half 8 times 11 times sine 0.7 is 28.345 minus a half of 8 squared times 0.7, which is 22.4. And I'm going to find the difference between those two things, which is 5.9455. Check the accuracy, I think it was three significant figures. Yeah, so three significant figures is 5.95 centimetres squared. So there we go, we used our formulae for the length of an arc, r theta, the area of a sector, half r squared theta. We also had to be aware of the sine rule for area and the cosine rule for finding a length, all in radians mode. I'll see you in the next video where we'll go through another example.